2017 question 3 of the mock paper 1 DEB was a complex number question. So on the question they told you z1 is equal to 3 plus 2i, z2 is equal to minus 1 plus i, tells you they're complex numbers, and it wants you to evaluate each of the following complex numbers in the form a plus bi. So for part 1 it wants you to get two z1s. So in other words, multiply z1, which is your 3 plus 2i, by 2. So write it down, use brackets when you're writing it down, and then multiply it out. So your 2 times your 3 gave you your 6, your 2 times your 2i gave you your 4i, and that's it done. Second part of it, it said you have to add z1 and z2. So in terms of addition or subtraction, advice would be is write them down using brackets first. So you write down a bracket with what z1 was, plus a bracket and what z2 is. Okay, then you can get rid of the brackets, making sure you pay note of the sign in the center, and then tidy it up. So we have 3 plus 2i minus 1 plus 2i. So when you sort that out, you get 2 plus 4i. And the third part, it says iz1, so that means you're multiplying your z1, which is your 3 plus your 2i, by an I. So when you're multiplying that out, you get 3i plus 2i squared. Your 2i squared, your I squareds become minus 1s, so that will become 3i minus 2. Second part, it asks you to plot them. So in terms of plotting them, you go out the real and up and down the imaginary. So for two z1s, you go to 6 plus 4i, and you do a dot, and remember to call it 2z1s. Right? You have 2 plus 4i, which is your z1 plus your z2, and then you have a 3i minus 2. So you have a minus 2 and a 3i, which is there, and that's your iz1. Okay, so plot them all in, making sure you don't fall for this one, okay, and label them correctly. Part 3, it says using your answers, explain what happens to each of the transformations. So your z equal to z1, the evaluation, your answer was 6 plus 4i, and basically when you look at your picture, it is saying that this line is twice as far from the origin as your z1 originally would have been. Okay, your z is equal to z1 and z2, so you get 2 plus 4i, so basically your point has moved from z1 to a z2 added onto it. But the most important one that you learn off, because it's very, very common, is when you multiply by an I, your point moves 90 degrees anti-clockwise. Okay, and that was your part A. Part B of the complex number question is a division. So it says find the complex number z3 such that z3 is equal to z1 divided by z2. Right, so you write down what your z1 is, you write down what your z2 is. Okay. For multiplication in complex numbers, you multiply top and bottom by the conjugate of the bottom. So the conjugate of the bottom is you write out the bottom, but you change the sign in front of the I part. So we had minus 1 plus 2i, so your conjugate is minus 1 minus 2i. And you multiply top and bottom by that. So write them down in brackets, and then remember to split the brackets correctly to multiply it. So you get 3 times minus 1 minus your 2i, and your 2i times your minus 1 minus your 2i. And at the bottom you have minus 1 times your minus 1 minus 2i, and then your plus 2i times your minus 1 minus 2i. So basically first thing, second bracket, second thing, second bracket. Multiply them out, and then you're going to tidy them up. So in terms of tidying them up, your I squareds are equal to minus 1. So we have a minus 4 I squareds, so that will become plus 4 at the top, and at the bottom exactly the same, minus 4 I squared, so it will become plus 4. So when you tidy them up, you notice if you've done it correctly, you should have no I values on the bottom. So in terms of this, we end up with a minus 3 plus a 4, which gives you a plus 1, and a minus 8i on top, and it's over 5. Now in terms of this answer is correct, but the question is asking you to give it in the form a plus bi, so to make it even more correct, you'd separate it into the two parts. So you've got 1/5 minus 8i over 5. Okay?